Good evening, and welcome to Sleep Odyssey. Tonight, we are not concerned with the immediate or the urgent. We are stepping away from the noise of our day into the quiet, echoing halls of history, into the mind of a man who reshaped our very understanding of reality. His name was Albert Einstein, but we will not meet him as the icon with the wild hair and the Nobel Prize. Not yet. We will meet him as a quiet child, baffled by a compass. We will walk with him as a frustrated student, a struggling patent clerk, a thinker lost in dreams of light and gravity. His story is not just one of physics. It is a story about the power of curiosity, the courage to question what everyone else accepts as true, and the profound, sometimes heavy, burden of genius. So, let go of the day. Settle into the comfort of this moment. Let your mind be still, and let us travel back to a small city in Germany in the late 19th century, where our story begins. Chapter 1. The Silent Oracle, 1879 to 1884. We begin in Ulm, Germany, in the year 1879. The German Empire is young, brimming with industrial confidence and iron-willed ambition. It is a world of rigid structures, of new factories, of a society that values order and discipline. On March 14th, in a small apartment, Albert Einstein is born to a secular, middle-class Jewish family. His father, Hermann, is an entrepreneur, a man of gentle optimism, though often struggling with his electrochemical business. His mother, Pauline, is a musician, a lover of culture, who fills their home with the precise, logical beauty of Mozart and Beethoven. The young Albert is not what you would call a prodigy. In fact, he is a source of some concern. He is a late talker. The family legend, perhaps embellished over time, is that he did not speak in full sentences until he was well past 3. Perhaps even 4. His parents, practical and grounded, even consulted a doctor. But this silence was not emptiness. It was perhaps an absorption. While other children learned the names of things, Albert seemed to be studying their nature. He was a quiet, watchful, intensely introspective child. He looked at the world with a deep, unsettling curiosity. The true moment of ignition, the event he would recall his entire life as a miracle, happened when he was about 5 years old and sick in bed. His father, Hermann, brought him a small gift to pass the time. It was a simple magnetic compass. To a child, it was a toy. But to Albert, it was a profound mystery. He turned it over, he twisted it, he pointed it in every direction, and yet, no matter what he did, the needle inside quivered, fought, and insistently pointed north. He could see the needle, but he could not see the force that moved it. There was nothing touching it, no springs, no strings, just an invisible, unwavering, powerful something, acting silently across empty space. He would later say he was so excited, he trembled and grew cold. This was the defining moment of his childhood. It was not a lesson from a book, nor a rule recited by a teacher. It was a direct confrontation with the unseen. The world, he suddenly understood, was not just the solid, predictable place it appeared to be. Beneath the surface of things, beneath the chairs and tables and the walls of his room, there was a hidden order, a deep, invisible ocean of forces. This small, handheld device shattered his simple, mechanical view of the world. It ignited in him a lifelong quest, not just to name the parts of the universe, but to understand the invisible rules that held it all together. The compass had posed the first great question of his life. And Albert Einstein, the quiet boy who was late to speak, would spend the rest of his days trying to find the answer. As he drifted off to sleep in his small bed in Ulm, the image of that trembling needle remained, a silent oracle pointing toward a future no one could have possibly imagined. Chapter 2: The Rebel in the Gymnasium, 1885 to 1894. In 1880, Hermann Einstein's business failed, and the family moved. They settled in Munich, a rising center of German culture and industry. It was here, as Albert grew, that his gentle curiosity would collide with the unyielding machinery of 19th-century German education. He was enrolled in the Luitpold Gymnasium. This was not a place that nurtured dreamers. It was a factory for producing obedient, disciplined subjects of the Kaiser. The air itself seemed thick with chalk dust and authority. The educational philosophy was simple: rote memorization. Facts were to be learned, not questioned. History was a list of dates. Mathematics was a set of rules to be drilled. Language was a series of grammatical structures to be parroted. The teachers, who often wore uniforms, were like drill sergeants, demanding absolute obedience and respect. For the young Einstein, this was torture. It was not just unpleasant, it was, in his mind, deeply violent to the spirit of learning. His mind, which had been set ablaze by the mystery of the compass, was now being told to sit still and memorize lists. He was not a poor student, not at first. His grades in mathematics and Latin were often excellent. He loved the internal logic of both, but he despised the method. He could not, and would not, simply accept the ipse dixit, the "because I said so," of his teachers. He would later write, "It is, in fact, nothing short of a miracle that the modern methods of instruction have not yet entirely strangled the holy curiosity of inquiry." This was the core of his rebellion. He asked questions. Why? How do we know this? What if it were different? To his teachers, this was not curiosity. It was insubordination. He was seen as lazy, disrespectful, and a disruptive influence. One teacher famously told him, "Einstein, you will never amount to anything." His internal world became his refuge. While his teachers droned on, his mind would escape the rigid benches of the classroom and wander. He discovered a small, holy book on Euclidean geometry. This book, given to him by a family friend, became his Bible. It was a revelation. Here was a system of perfect logical thought. Starting from just a few simple axioms, self-evident truths, one could build an entire, magnificent universe of proofs and theorems. It was beautiful, clean, and true in a way that his school's arbitrary rules were not. He devoured it, mastering its contents with a passion that baffled his teachers. At the same time, his mother, Pauline, insisted he learn the violin. He hated the mechanical drills, the repetitive practice. But then, he discovered the sonatas of Mozart, and suddenly the music clicked, just as geometry had. He saw in Mozart's compositions the same grace, the same hidden mathematical structure, the same logical elegance as Euclid. Music and math, he realized, were not separate. They were two different languages for describing the same divine underlying order. His time in Munich was a crucible. It forged in him a deep, abiding suspicion of arbitrary authority. It taught him that true knowledge did not come from obedience, but from independent critical thought. And it solidified his retreat into his own mind, a place where he, and not some gymnasium prefect, could ask the questions that truly mattered. In 1894, his father's business failed again. The Einstein family packed their bags and moved once more, this time to Milan, Italy. They left Albert behind, telling him to stay and finish his schooling, to get his diploma. He lasted only a few more months. The gray, oppressive atmosphere of the school, now combined with the loneliness of his family's absence, became unbearable. In an act of profound defiance, Albert Einstein, at the age of 15, faked a doctor's note claiming nervous exhaustion. He packed a small bag, walked out of the Luitpold Gymnasium, and boarded a train south over the Alps to Italy. He was a high school dropout. He had no diploma, no clear prospects. But he was, for the first time, free. And as the train carried him toward his family, he was already pondering a new question, one that had been forming in his mind for years. A question not about a compass, but about light itself. Chapter 3. The Light Beam Rider, 1895 to 1896. Arriving in Italy was like emerging from a long, dark tunnel into blinding sunlight. The contrast to the rigid, gray world of Munich could not have been more extreme. He found his family in Pavia, and for a few glorious months, he simply was. He wandered through the art-filled streets, helped at his father's struggling factory, and felt the warmth of a culture that seemed to celebrate beauty and freedom over strict regimentation. He was free from the spirit-killing drills of the gymnasium. His mind, finally unbound, was electric. It was here, in the hills of Italy, that the 16-year-old dropout formulated his first great Gedanken experiment, a thought experiment. This is a practice he would perfect, a tool more powerful to him than any laboratory. He would sit quietly, close his eyes, and run a simulation in the laboratory of his own imagination. The question that obsessed him was this: what would the world look like if I could ride on a beam of light? Let us pause and follow his mind. He had been studying the work of James Clerk Maxwell, the Scottish physicist who had recently proven that light was an electromagnetic wave, a traveling disturbance of electric and magnetic fields, moving at a constant, incredible speed. C. So, Albert imagined himself running, faster and faster, until he caught up with a wave of light, riding alongside it like a surfer on a wave. What would he see? According to all the physics he knew, the wave should appear frozen. He would be looking at a static, unmoving wave of electric and magnetic fields, stationary in space. But here was the paradox that seized his young mind. According to Maxwell's own equations, such a thing was an impossibility. A static light wave cannot exist. Light, by its very definition, is a phenomenon of change, of motion. If it's not moving at speed c, it's not light. This was a deep fundamental contradiction. The laws of motion, Newton's, and the laws of light, Maxwell's, seemed to be at war with each other. One said you could catch up to anything. The other said you absolutely could not catch up to light. This paradox, born in the imagination of a 16-year-old, was not a passing fancy. It was a crack in the very foundation of physics. He didn't know the answer, but he knew the question was vital. This idyllic Italian interlude, however, could not last. He was a dropout without a country. His father's business was still failing, and Albert needed a path forward. He decided he would try to get into the prestigious Swiss Federal Polytechnic, the ETH, in Zurich. There was a problem. He didn't have a high school diploma. He traveled to Zurich to take the entrance exam, and though he excelled in mathematics and physics, he failed spectacularly in the other subjects: French, chemistry, and biology. He was not admitted. But the director of the Polytechnic, impressed by his physics scores, saw the spark. He offered a compromise: go to a Swiss cantonal school in the nearby town of Aarau for 1 year, get your diploma, and then you will be admitted. And so Einstein moved to Aarau. This move would prove to be just as transformative as his escape from Munich. The school in Aarau was the complete opposite of the Luitpold Gymnasium. It was a progressive liberal institution based on the methods of the Swiss educational reformer Pestalozzi. Here, students were encouraged to think for themselves, to conduct experiments, to nurture their own curiosity. He lived with the family of one of his teachers, Jost Winteler. The Winteler household was a vibrant, intellectual, and anti-authoritarian environment. He was treated as a son, debated politics and philosophy at the dinner table, and, for the first time, felt truly at home in an academic setting. It was in this nurturing environment that Einstein made another, more personal, decisive break. In 1896, at the age of 17, with his father's permission, he went to the German consulate and formally renounced his German citizenship. It was a rejection of the militarism, the rigid authority, and the anti-Semitism he saw growing in his birth country. For the next 5 years, Albert Einstein would be stateless, a man belonging to no nation. His only true citizenship was in the realm of ideas. He thrived in Aarau, and this time he passed his exams with ease. The doors to the ETH Zurich were finally open. The paradox of the light beam rider, still unsolved, waited patiently in his mind. Chapter 4. The Bohemian Student, 1896 to 1900. Zurich, at the turn of the 20th century, was a magnet for restless minds. It was a vibrant, liberal city, a haven for radicals, artists, and thinkers from all over Europe, including a young Russian revolutionary named Vladimir Lenin, who was, at that very time, studying in the same city. Into this intellectual ferment walked Albert Einstein, now 17, stateless, and enrolled at the prestigious ETH. He was finally at one of the finest universities in the world for physics and mathematics, and he proceeded to cut most of his classes. This was not laziness. It was a conscious choice. He had come to a profound realization in Aarau. He could learn far more effectively on his own, reading the original papers of the masters, than by sitting in what he considered to be dry, outdated lectures. His physics professor, Heinrich Weber, who had once admired him, grew deeply frustrated. Weber's lectures were on classical physics, but he largely ignored the revolutionary new work of Maxwell. This, for Einstein, was unforgivable. Why, he wondered, would they teach the past when the present was so exciting? So, while his classmates dutifully took notes, Einstein was in his rented room, or in a bustling Zurich cafe, devouring the original works of Boltzmann, Helmholtz, and Maxwell. He was, in his own words, a bohemian, living on a modest allowance from his family, playing his violin, and arguing about physics and philosophy with a self-assurance that bordered on arrogance. This arrogance would cost him. He was a brilliant mind, but he was not a good student. He was seen by his professors as a lazy dog, a clever but undisciplined young man who lacked the requisite respect for his elders. But this period was not defined by the classes he skipped. It was defined by the relationships he formed. The most important, without question, was with a fellow student in his small physics class. Her name was Mileva Maric. Mileva was a remarkable person in her own right. She was from Serbia, 4 years older than Albert, and the only woman in their entire physics cohort. She had overcome immense social barriers to be there. She was fiercely intelligent, deeply serious, and carried a melancholy that stemmed from a limp she had from birth, and the constant struggle of being a woman in a man's world. They were two outsiders, drawn together by an intense shared passion. Their relationship was a partnership of the mind, long before it was anything else. Their letters to each other, which were discovered decades later, are filled not just with youthful romance, but with physics. They debate papers, they discuss their work, they share ideas. This relationship became the center of Einstein's emotional and intellectual life. She was his equal, his sounding board. He called her his Doxeral, or little doll, and she called him her Johannsel, or Johnny. There was another friend, a quieter but equally crucial one, Marcel. Grossmann? Grossmann was the model student Einstein was not. He was meticulous, disciplined, and attended every lecture, Seeing Einstein's brilliance, but also his chaotic approach to his studies, Grossman made a pact. He would share his immaculate, detailed lecture notes, allowing Einstein to skip class and study on his own, so long as Einstein helped him with the physics. It was a bargain that would, quite literally, save Einstein twice. The first time was in 1900 at the final examinations. Einstein, having skipped most of the lectures, had to cram 4 years of physics and mathematics in just a few months. He did it using one tool, Marcel Grossman's notebooks. He later said, "Marcel, you saved me. Without you, I would have certainly been lost." He passed, but just barely. His grades were unremarkable, and his professors had not forgotten his arrogance. In 1900, Albert Einstein graduated from the F. He was ready to take his place in the world of academia, to get a teaching position, and to finally solve the paradox of the light beam rider. But the academic world wanted nothing to do with him. Professor Weber, still incensed, allegedly went out of his way to block him, writing negative recommendations. Every application he sent for an assistantship at every university he could think of was met with silence or polite rejection. He had his degree. He had his brilliant, unpublished ideas. But he was, once again, unemployed and utterly adrift. The 20th century had begun, and Albert Einstein, the man who would define it, was a failure. Chapter 5. The Wilderness Years, 1900–1902. The 2 years that followed his graduation were perhaps the darkest of Einstein's life. He called them his wilderness years. He was floating, unmoored, in a world that had no place for him. He was 21 years old, a graduate of a prestigious university, yet he could not find work. He scrambled to make ends meet, placing ads offering to tutor students in physics and math. He took temporary, unfulfilling teaching jobs that barely paid his rent. His letters from this time are tinged with a quiet desperation. He writes to his sister Maja of his miserable state. His father's business in Italy collapsed completely, and his parents' anxiety about their unsuccessful son weighed heavily on him. He felt like a burden. All the while, his mind was still wrestling with the giants of physics. He was still thinking about the nature of light, about the ether, the invisible medium everyone assumed light traveled through, and about the contradictions in Maxwell's equations. He even completed his first scientific paper, a deduction on the forces between molecules, and submitted it to a prestigious journal. It was published, but it was largely ignored. He was a physicist with no one to talk to, a thinker with no audience. And in this period of professional turmoil, his personal life became intensely complicated. His passionate relationship with Mileva Maric had continued against the strenuous objections of his mother. Pauline Einstein despised Mileva. She saw her as a bookworm, too old, too intellectual, and not Jewish. She famously told her son, "You are ruining your future. No decent family will have her." But Albert, in his typical anti-authoritarian fashion, dug in his heels. Their love was a defiance. In 1901, while visiting Albert in Lake Como, Mileva became pregnant. This was a catastrophe for an unmarried couple of the era. For Albert, an unemployed graduate struggling for a foothold, it was a profound complication. For Mileva, it was the end of her academic career. The shame, the stress, and the physical demands of the pregnancy forced her to abandon her own thesis, which she was just one step away from completing. She returned to her family in Serbia to have the child in secret. In early 1902, she gave birth to a daughter named Liesel. The fate of Liesel is one of the great sad mysteries of Einstein's life. She was never spoken of. She disappears from the historical record almost immediately. The letters between Albert and Mileva mention her sickness, likely scarlet fever, and then silence. The prevailing theory is that she either died in infancy or was given up for adoption. We do not know if Einstein ever saw his firstborn child. The weight of this secret, the grief and the shame, must have been immense, a hidden anchor in the turbulent waters of his life. He was at his lowest ebb. He was poor, seemingly rejected by his chosen field, estranged from his family, and now, grappling with the secret birth and likely loss of his child. The world had proven to be a cold, indifferent place. It was in this moment of near total despair that a lifeline finally appeared. It came from his old friend, the man with the beautiful notes, Marcel Grossmann. Grossmann's father knew the director of the Swiss patent office in Bern. He put in a good word for his son's brilliant, struggling friend. It was not an academic job. It was a civil service post. In June 1902, Albert Einstein was hired as a technical expert third class at the Swiss Federal Office for Intellectual Property. The salary was modest, but it was stable. It was security. It was a rescue. He moved to Bern, and in 1903, he and Mileva, now reunited, were finally married. The shadow of Liesel hung over them, but they were determined to build a life. Einstein, the patent clerk, settled into his new routine. He could not have known that this bureaucratic desk job in this quiet cobblestone city was not a detour. It was the crucible. It was the very place where he would, in secret, unlock the universe. Chapter 6, The Olympia Academy, 1902-1904. The Bern Patent Office was, in a strange way, the perfect job for Albert Einstein. The work was precise, focused, and intellectually engaging, but in a contained way. He would sit at his wooden desk and analyze patent applications, blueprints for newfangled inventions, perpetual motion machines, and industrial gadgets. His job was to look at a drawing and a description, and in his mind, determine if the machine would work. Was it practical? Did it violate the known laws of physics? This daily exercise was a mental whetstone. It trained him to cut through complex, often muddled language to find the core principle of an idea. It taught him to spot flaws in logic, to see the hidden assumptions. He became a master at visualizing a concept, at seeing its essence. And crucially, the work was not all-consuming. He became so efficient at his duties that he could often finish his day's tasks in just a few hours. This left him, as he sat at his government desk, with time to think, time to let his mind wander back to the paradox of the light beam rider. The patent office was his worldly cloister, a place where he was paid to be practical, freeing his mind to be revolutionary. But he was not entirely alone in his intellectual life. Soon after arriving in Bern, he placed another advertisement in the newspaper. This time, it was not for tutoring, but for conversation. He sought students for private lessons in physics and mathematics. A few people responded. Two of them, Maurice Solovin, a philosophy student from Romania, and Konrad Habicht, a mathematician, would become his closest friends. They did not become a class, they became a club. They met several nights a week in Einstein's small apartment, long after Mileva and his new son, Hans Albert, born in 1904, had gone to sleep. They jokingly, grandiosely called themselves the Olympia Academy. Their ritual was simple. They would have a frugal meal, perhaps some sausage, cheese, and fruit, and then, over cups of tea and clouds of pipe smoke, they would read and they would argue. They did not read the latest physics journals. They read the classics. They read Spinoza, the philosopher who saw God in the mathematical harmony of the universe. They read David Hume, the the skeptic who questioned the very nature of cause and effect. They read Poincaré, the mathematician who was already questioning the absolute nature of time. This was not a study group. It was an intellectual furnace. For Einstein, it was the university he had always craved. Solovini and Habicht were not his students. They were his intellectual sparring partners. They were smart, curious, and, most importantly, they did not care about academic tradition. They challenged his assumptions. They forced him to articulate his half-formed ideas with crystal clarity. In these smoky, late-night sessions, Einstein honed his arguments. He debated the nature of space. He wrestled with the concept of time. He questioned the ether, that invisible jelly-like substance that all physicists, including Maxwell, assumed filled the universe and carried light waves. What if, Einstein proposed, there was no ether? What if light was not a wave in a medium, but a thing in itself? And what about time? Hume and Poincaré had made him doubt it. We assume time is absolute. We assume that a second in Bern is the same as a second on Mars or on a distant star. But how do we know? What if the very act of measuring time, of synchronizing clocks, was the key? The Olympia Academy was the forge. Here, his vague intuitions were hammered into sharp, logical arguments. He was connecting the dots between Hume's skepticism, Spinoza's harmony, and Maxwell's equations. A storm was gathering in his mind. The seeds planted by the compass in Ulm, the paradox of the light beam in Aarau, and the late-night debates in Bern were all beginning to converge. The quiet third-class patent clerk was on the verge of something monumental. The year 1905 was approaching. Chapter 7. The Annus Mirabilis, 1905. The year is 1905. We are in Bern, in the small apartment on Kramgasse 49. Albert Einstein is 26 years old. He is a husband, a new father to Hans Albert, and a patent clerk. To any outside observer, he is an unremarkable man. He has published a couple of minor papers. He has a respectable, if dull, job. He has failed to secure the academic post he so desired. But in the laboratory of his mind, a revolution is igniting. In a span of just a few months, working in his spare time, with no academic colleagues, no library save for his own small collection, and no laboratory save for his own imagination, Albert Einstein will write and publish 4 papers. 4 papers that will completely and irrevocably change our perception of the universe. It is his Annus Mirabilis, his miracle year. The first paper, The Light Quantum. The first paper, published in March, tackled a puzzle called the photoelectric effect. It was a known curiosity. If you shine a light on a piece of metal, it can knock electrons loose. But, strangely, a brighter light didn't necessarily work better. A faint blue light worked, while a very bright red light did nothing. Einstein's solution was audacious. He proposed that light doesn't just behave as a continuous wave, as Maxwell had said. He argued that light also travels in tiny, discrete packets of energy, little bullets of light. He called them light quanta. We now call them photons. A blue light bullet simply had more punch, more energy than a red one. It wasn't about the brightness, the number of bullets, but the energy of each individual bullet. This was more than just solving a puzzle. This was the birth of quantum theory. He was saying that light, the most fundamental thing in the universe, was both a wave and a particle. It was a bizarre, contradictory idea that even he found deeply disturbing. This, not relativity, is the work that would eventually win him the Nobel Prize. The second paper. The Existence of Atoms. Just 2 months later, in May, he published his doctoral thesis. It was, on the surface, less glamorous. It was about Brownian motion, the strange random jiggling of microscopic particles, like pollen, suspended in water. No one knew why they jiggled. Einstein's paper provided the math. He showed that the pollen was being jostled, bombarded from all sides by something invisible, the water molecules themselves. At this time, in 1905, the existence of atoms and molecules was still a theory. It was a useful idea, but not a proven fact. Einstein's paper provided the first experimental proof. He had, in essence, proven that atoms were real. He had made the invisible visible, the third paper, the fabric of reality. And then, in June, came the thunderclap, the culmination of the 10-year-old question, the solution to the light beam rider paradox. The paper was titled, "On the Electrodynamics of Moving Bodies." We know it as the special theory of beam. Relativity. His solution was to throw out the one thing everyone took for granted, that time and space are absolute, fixed, and separate. Einstein started with two simple postulates. 1. The laws of physics are the same for all observers in uniform motion. 2. The speed of light in a vacuum is always the same, no matter who measures it or how fast they are moving. From these two simple ideas, the logical consequences were shattering. To keep the speed of light constant for everyone, something else had to give. That something, Einstein proved, was time and space. He showed that for an observer moving very, very fast, time itself slows down. A clock on a speeding train, a very, very fast train, would tick slower than a clock on the station platform. He also showed that space contracts. That same train would appear to be physically shorter to the person on the platform. Time and space were not a rigid absolute stage on which the universe performed. They were a dynamic, interwoven fabric, space-time, and his theory solved the paradox. You can't ride a beam of light because as you approach the speed of light, your time slows to a near stop and your length shrinks to nothing. The speed of light is the ultimate cosmic speed limit. The fourth paper, The Equation of the Cosmos, he wasn't done. As an afterthought, a postscript to his relativity paper, he published a tiny 3-page supplement in September. He explored a further consequence of his new theory. If time and space are relative, what about mass? He found that mass, too, is not constant. It is, in fact, a form of energy. He showed that a tiny amount of mass could be converted into a stupendous amount of energy. The relationship between them was captured in the most famous and perhaps most terrifying equation in history, E equals mc squared, energy equals mass times the speed of light squared. The year 1905 came to a close. Albert Einstein, the patent clerk, had published these 4 papers in the Annalen der Physik, the leading physics journal, and the world did not immediately notice. He was still at his desk, stamping patent applications. But in the highest towers of academia, a few minds had been electrified. Max Planck, the dean of German physics, was one of the first to grasp the profound implications. The name Einstein began to be whispered. The silence was about to break, and the lonely life of the patent clerk was about to end forever. Chapter 8. The Ascent of Herr Professor, 1906-1911. The seeds planted in 1905 were slow to germinate, but they were powerful. In the quiet offices of theoretical physicists across Europe, men like Max Planck were reading the Annalen der Physik with growing astonishment. Who was this Einstein in Bern? Einstein himself remained at the patent office, his worldly cloister, for several more years. He was promoted to technical expert, second class. He and Mileva continued their life, but the ground was shifting. He was now in regular correspondence with Planck, the very center of the physics establishment. His isolation was over. In 1908, he finally received the academic recognition he had craved. He was given a Privatdozent, a license to teach, at the University of Bern. It was an unpaid position. He would work at the patent office all day, and then, in the evening, walk to the university to lecture to a handful of students. Sometimes, only his friends from the Olympia Academy would show up. His lectures were, by all accounts, unconventional. He was often disorganized, spoke softly, and would get lost in his own equations, but his passion was magnetic. The first full-time job offer came in 1909 from the University of Zurich. It was a modest post as an associate professor. The pay was hardly better than his patent office salary, but it was in. He was, at last, Herr Professor Einstein. He, Mileva, and their son, Hans Albert, moved back to the city where they had been students. But things were different. Einstein was now a recognized, if still junior, member of the scientific community. But this period was also one of growing strain in his personal life. His ascent into the world of physics seemed to coincide with a growing distance from Mileva. The passionate intellectual partnership that had fueled his early years was beginning to fade. Mileva, who had sacrificed her own scientific ambitions, was now the wife of a professor, isolated, and reportedly prone to bouts of deep depression. The birth of their second son, Edward, in 1910, brought new joys but also new stresses. Einstein's focus was almost singular. He was a whirlwind of activity, teaching, writing, and, most of all, thinking. For his miracle year work was not an end. It was a beginning. His special theory of relativity was beautiful, but it was incomplete. It had a glaring hole. It only applied to uniform motion, a steady, constant speed. It said nothing about acceleration. It also said nothing about the one force that governed the entire cosmos, gravity. Newton's theory of gravity, of an invisible rope pulling the apple to the earth and the moon to the earth, had stood unchallenged for over 200 years. But Einstein knew it was wrong. Newton's gravity was instantaneous. It was a force that acted across the void of space in no time at all. But Einstein's own special relativity had proven that nothing can travel faster than light, not even gravity. This was another profound contradiction. He became obsessed with this new problem, how to incorporate gravity and acceleration into his theory. His career continued its rapid climb. In 1911, he was lured away from Zurich to the German University in Prague, a major post with a full professorship. He was now, unequivocally, one of the leading physicists in Europe. It was in Prague, in 1911, that he had what he would later call his happiest thought. He was sitting in his chair, perhaps at the patent office years earlier. The memory was fluid. And the thought struck him. If a person falls freely, they will not feel their own weight. Imagine a man in an elevator and the cable snaps. In that moment of free fall, he would be weightless. A ball he dropped would float in front of him. If he tried to stand on a scale, it would read 0. In that falling elevator, the effects of gravity have vanished. This simple, brilliant insight was the key. Einstein realized that acceleration and gravity were not just related. They were, in a deep sense, indistinguishable. This was his principle of equivalence. If gravity could be switched off simply by accelerating, then perhaps gravity was not a force at all. Perhaps gravity was a property of space-time itself. With this thought, the path to his greatest masterpiece, the general theory of relativity, was laid open before him. But the journey down that path would be the most arduous intellectual struggle of his life. Chapter 9. The Mountain of General Relativity, 1912-1915. In 1912, Einstein was lured back to Zurich, this time to his alma mater, the F, as a full professor. He returned with a singular burning mission to find the mathematical language that would describe his happiest thought. He knew what he wanted to say. Gravity is not a force pulling things. Gravity is the curvature of space-time. Imagine space-time as a flat, stretched rubber sheet. If you place a bowling ball, like the sun, in the middle, the sheet warps and curves. Now, if you roll a small marble, like the Earth, nearby, it doesn't fall toward the bowling ball. It simply follows the curve in the rubber sheet. This was his beautiful, revolutionary idea. The Earth is not being pulled by the sun. The Earth is simply following the straightest possible path through a space-time that has been curved by the sun's mass. The idea was elegant. The mathematics, however, were a nightmare. Einstein was a brilliant physicist, but he was not a pure mathematician. The tools needed to describe a curving, four-dimensional geometry were far beyond his abilities. He didn't even know what they were called. He turned, once again, to his old, reliable friend, Marcel Grossmann. Grossmann was now a professor of mathematics at the ICH. Einstein, in a state of near desperation, went to him. Grossmann, he famously said, "You must help me or I'll go mad." Grossmann identified the obscure mathematics he needed, tensor calculus, developed decades earlier by Bernhard Riemann. It was a branch of mathematics so complex, so abstract, that few people in the world understood it. For the next several years, the two friends collaborated. Einstein, the physicist, providing the conceptual insights. Grossmann, the mathematician, guiding him through the labyrinth of tensors. They published papers together, sketching out the N-Twerf theory. It was close, but it was flawed. It didn't quite work. In 1914, Einstein's life was upended again. He was offered the most prestigious position in all of German science, a research professorship at the Prussian Academy of Sciences in Berlin, and director of the new Kaiser Wilhelm Institute for Physics. It was the pinnacle. He would be at the very center of the scientific world, working alongside giants like Max Planck. He would have no teaching duties. He would be paid, handsomely, simply to think. He accepted. But this move came at a terrible personal cost. His marriage to Mileva had completely disintegrated. The strain of his all-consuming work, their personal differences, and his own infidelities, he had begun a relationship with his cousin, Elsa Löwenthal, led to a bitter separation. Mileva and his two sons stayed behind in Zurich. He moved to Berlin alone, and just as he settled in August 1914, the world exploded. The assassination of Archduke Franz Ferdinand triggered the Great War. World War I had begun. Berlin, which was supposed to be his scientific
utopia, became a fortress of militaristic fever. His colleagues, including Planck, were swept up in patriotic fervor. 93 of Germany's most prominent intellectuals signed the Manifesto of the 93, a document defending Germany's actions. Einstein was horrified. A dedicated pacifist, he saw the war as a collective, primal madness. He refused to sign. Instead, he co-authored a Manifesto to the Europeans, calling for peace and a unified Europe. It got only 3 signatures. He was now profoundly isolated, a pacifist in a militaristic capital, a Jew in an increasingly nationalistic state, separated from his children, and stuck, agonizingly, on the final, correct equations for his theory of gravity. It was in this state of personal and political isolation that he entered the final, frantic sprint. In the autumn of 1915, he learned that David Hilbert, a mathematician in Göttingen and perhaps the greatest living mathematician on Earth, had become interested in his theory. Hilbert, after hearing Einstein lecture, was now working on the same problem. A desperate race began. For 4 weeks in November 1915, Einstein and Hilbert exchanged letters and papers. Einstein, working with a frantic, sleepless energy, finally saw the flaw in his old equations. He corrected his math, abandoned a previous assumption, and the pieces clicked into place. In a series of 4 lectures to the Prussian Academy, he presented his final, correct general theory of relativity. The field equations were beautiful, powerful, and complete. He had published just days before Hilbert, who had, independently, arrived at the exact same equations. Though there was some dispute, Hilbert himself gave Einstein full credit for the theory. Einstein was exhausted, but triumphant. He had, in his own words, finally succeeded. He had rewritten the laws of the cosmos, replacing Newton's invisible rope with the elegant, silent curvature of space-time. It was his masterpiece. But it was just a theory, and with Europe tearing itself apart, there was no way to prove it. Chapter 10. The Bending of Starlight, 1919. The war ended in 1918, leaving Europe in ruins. A scar of mud, wire, and incomprehensible loss stretched across the continent. A generation was shattered. The old, confident world of empires and certainty was gone forever, replaced by a deep collective trauma and a desperate hunger for something new, something transcendent. In Berlin, Einstein had survived the war, a lonely pacifist island in a sea of patriotic fervor. His general theory of relativity, published during the conflict, was a magnificent edifice, but it remained unproven. His theory made several predictions, but one was testable. It predicted that gravity, because it curves space, must also curve light. A beam of light from a distant star, passing close to a massive object like our sun, should be bent by the sun's gravity. It would be like a marble rolling past the bowling ball on the rubber sheet. Its path would deflect. We can't see stars during the day, so the only way to test this was to observe the stars near the sun during a total solar eclipse. The eclipse would blot out the sun's light, allowing astronomers to photograph the pinpricks of light from the stars just beyond its rim. By comparing this photograph to a photo of the same stars at night, when the sun is not there, they could measure if the stars' positions had shifted. If they had shifted, and by the exact amount his equations predicted, Einstein was right. If not, his theory was just a beautiful piece of mathematics. A British astronomer, Arthur Stanley Eddington, heard of this prediction. Eddington was a brilliant physicist, a Quaker, and, like Einstein, a dedicated pacifist who had opposed the war. Eddington saw this as more than a scientific experiment. In a world poisoned by nationalism, he saw a chance for a British scientist to prove the theory of a German scientist. It would be a powerful symbol of healing, a demonstration that science and truth belong to no single nation. He secured funding and organized 2 expeditions to observe the total solar eclipse of May 29, 1919. One team, led by Eddington himself, went to the island of Príncipe, off the coast of West Africa. The other team went to Sobral, Brazil. The day of the eclipse was tense. In Príncipe, the weather was terrible. It rained all morning. The clouds only parted for a few precious, fleeting moments during totality. Eddington managed to get a handful of photographic plates, but he was worried. Were they good enough? In Sobral, the weather was better, but the primary telescope's focus blurred. A backup telescope, however, produced clear images. The teams returned to England. The delicate, painstaking work of measuring the microscopic shifts in the star positions began. For months, the world of physics held its breath. Einstein waited in Berlin. He was outwardly calm, affecting a cool confidence. When a student asked him what he would do if the experiment didn't prove his theory, he famously replied, "Then I would feel sorry for the dear Lord. The theory is correct." But inwardly, he must have been on edge. Everything was on the line. On November 6, 1919, the results were announced at a joint meeting of the Royal Society and the Royal Astronomical Society in London. The atmosphere was electric, described by attendees as like a Greek drama. The Astronomer Royal, Sir Frank Dyson, stood. He announced that the measurements from both Sobral and Principe confirmed Einstein's prediction. The starlight had bent, and it had bent by the exact amount general relativity predicted. The next day, the Times of London ran a now legendary headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." Overnight, Albert Einstein became the most famous scientist on Earth. He was no longer just Herr Professor Einstein. He was Einstein, a global symbol. His face, his name, his ideas, though few truly understood them, became synonymous with the word genius. He was a new kind of celebrity, a secular prophet for a disillusioned world, a man who had, from the quiet of his own mind, deciphered the very architecture of the cosmos.
Chapter 11. The Global Icon, 1920-29. The confirmation of general relativity transformed Albert Einstein from a respected physicist into a global phenomenon. His name became a household word, a synonym for supreme intellect. His face, increasingly framed by a halo of wild, graying hair, became the very image of the absent-minded, benevolent genius. He was mobbed by crowds wherever he went. He embarked on world tours, visiting the United States, England, France, and Japan. He was no longer just a scientist. He was an ambassador for science, for reason, and, increasingly, for his own political ideals. In 1921, he visited America for the first time. He was there ostensibly to raise funds for the planned Hebrew University in Jerusalem, a cause he passionately supported as part of his growing identification with his Jewish heritage and the Zionist movement. But the trip was a media circus. He was greeted like a movie star, given the key to New York City, and shuffled from one grand reception to another. This new life was a strange fit. He was a deeply private man, a lone traveler, as he called himself, who valued quiet contemplation above all. And yet, he found himself spending his days in formal dinners, giving speeches, and shaking hands. He and his second wife, Elsa, who was far more comfortable with the fame than he was, were constant public figures. He endured the empty noise of it all because he understood that his fame was a tool. It was a platform. He could now speak, and the world would listen. And so he spoke. He spoke out for pacifism, for international cooperation, and against the rising tide of nationalism. He was a voice for a new, borderless, post-war world. In 1922, his fame was cemented. He was awarded the Nobel Prize in Physics for 1921. But here, there is a fascinating and telling detail. He was not awarded the prize for his masterpiece, general relativity. The theory was still considered too new, too complex, and too controversial for the conservative Nobel Committee. Instead, the prize was awarded for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. It was for his 1905 paper, the one that had launched the quantum revolution. It was a revolution that Einstein himself, ironically, was already beginning to find deeply troubling. He was now at the pinnacle of his profession, living and working in Berlin, the glittering, chaotic, brilliant heart of the Weimar Republic. It was the golden age of physics, and he was its king.
But in the background, a new debate was brewing, a debate about the very soul of physics. And in the beer halls and back alleys of Munich, a dark nationalist resentment was festering. The same forces he had fled as a boy in Munich were rising again. And this time, he, Albert Einstein, the world's most famous Jew, was one of their primary targets. Chapter 12, The Dice of God, 1925 to 1930. While the public saw Einstein as the lone genius of relativity, a second parallel revolution had been unfolding: quantum mechanics. This was the theory of the very, very small, the bizarre, ghostly world of electrons, photons, and atoms. And it was a world that Einstein, despite having helped create it with his 1905 photoelectric paper, found deeply, philosophically horrifying. The new generation of physicists, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, were developing a theory that was unlike anything in history. In the old classical world of Newton and Einstein, the universe was predictable. If you knew the position and velocity of a billiard ball, you could predict its entire future path. The universe was a great clockwork, wound by God, and obeying perfect, unwavering laws. Einstein's relativity, for all its strangeness, was still a classical theory. It described a universe that was ordered, knowable, and absolute in its laws. Quantum mechanics proposed something radically different. It said that at the subatomic level, the universe is not predictable. It is a game of chance. Heisenberg's uncertainty principle stated that you could never, even in theory, know both the exact position and the exact momentum of an electron. The more you knew of one, the less you could know of the other. Schrödinger's equation described electrons not as tiny balls, but as waves of probability, smears of potential existence. An electron wasn't here or there. It was in a superposition of all possible places at once, until the moment you looked at it. The very act of observation, the theory said, collapsed the wave and forced the particle to choose a location. To Einstein, this was madness. It was not physics, it was mysticism. This disagreement came to a head in a series of legendary debates at the Solvay conferences in Brussels, particularly the one in 1927. These conferences brought together all the greatest minds in physics. The public image is of Einstein, the aging lion, versus Niels Bohr, the great Danish physicist and father figure of the new quantum school. Einstein would spend his days devising brilliant thought experiments, or Gedankenexperiment, designed to show a loophole in quantum theory, a way to defeat the uncertainty. He would present his challenge to Bohr over breakfast. Bohr would spend the entire day in a state of agitation, pacing and agonizing, before finally, by dinner, finding the flaw in Einstein's argument, often using Einstein's own relativity to do it. The most famous exchange captures the entire philosophical divide. Frustrated, Einstein finally declared, "God does not play dice with the universe." To which Niels Bohr, equally frustrated, is said to have replied, "Albert, stop telling God what to do." This was the great rift of his life. He, the great revolutionary, had become the great conservative. He could not accept that the universe, at its most fundamental level, was governed by randomness and probability. He believed that quantum mechanics was just an incomplete, temporary theory. He believed that beneath the apparent randomness, there must be a deeper, hidden set of rules, hidden variables, that, if we were only clever enough, we could find. He would spend the rest of his life searching for this deeper, unified theory, a quest that would ultimately isolate him from the very mainstream of physics he had helped to create. He was, as he would later say, a relic, a man left behind by the revolution he had started. Chapter 13. The Unraveling World. 1929-1933. While Einstein was debating the nature of God's dice, the world outside the university walls was darkening. The late 1920s in Berlin were a time of dazzling, decadent, and frantic creativity. It was the Weimar Republic, a fragile experiment in democracy, but beneath the surface, the foundations were cracking. The economic devastation of the 1929 Wall Street crash hit Germany harder than perhaps any other nation. Unemployment skyrocketed. Millions were desperate, angry, and looking for someone to blame. And in this fertile ground of fear, the Nazi Party, led by Adolf Hitler, was rapidly gaining power. Einstein, the world's most prominent Jew, its most outspoken pacifist, and the living symbol of the corrupt intellectual Weimar culture, became a primary target. This was not new. Anti-Semitism had shadowed him for years. But now it was becoming organized, mainstream, and violent. An anti-relativity movement had formed, funded by extremist groups. They held rallies, decrying his work as Jewish physics, a hoax designed to undermine German culture. Scientists, jealous of his fame or blinded by ideology, joined the chorus. A book was published titled 100 Authors Against Einstein. He tried to laugh it off. "If I were wrong," he said, "one author would have been enough." But the threat was not intellectual. It was physical. His life was openly threatened. A magazine published his photograph with the caption, "Not yet hanged." He had built a small summer house in the village of Kaputh, outside Berlin. It was his sanctuary, a place to sail his small boat and think. But even there, he was not safe. He was warned that the Nazis had him on an assassination list. In December 1932, Einstein and his wife, Elsa, left Germany for their annual winter trip to the United States, where he was a visiting fellow at the California Institute of Technology in Pasadena. 1 month later, on January 30th, 1933, Adolf Hitler was appointed Chancellor of Germany. The unraveling was immediate and total. The Reichstag fire, the suspension of civil liberties, the organized boycotts of Jewish businesses. Einstein watched, horrified, from across the ocean. He knew instantly that he could never go back. From California, he watched as the civilization he had been a part of collapsed into barbarism. His friends and colleagues who were Jewish or communists or simply liberal were being systematically purged from the universities. In March 1933, he made his public declaration. He issued a statement condemning the new regime's brutality and persecution. The Nazi government retaliated instantly. They ransacked his apartment in Berlin. They seized his bank accounts. They publicly declared him an enemy of the state. Most chillingly, they raided his beloved summer house in Kaputh, searching for a non-existent weapons cache. Einstein, the stateless man who had renounced his German citizenship in 1896 and who had
cautiously reclaimed it as a sign of faith in the Weimar Republic, was now in exile once more. He and Elsa sailed back to Europe, but not to Germany. They landed in Belgium, where they were given protection by the king. For a few months, he was a man without a home, his life in mortal danger. Offers poured in from universities around the world. He chose a quiet, unassuming town in New Jersey, home to a new, peculiar institution. In October 1933, Albert Einstein, the greatest refugee in a world full of refugees, arrived in Princeton, New Jersey, to join the Institute for Advanced Study. He would never, ever set foot in Europe again. Chapter 14, The Lion in Winter, 1933-1939. Princeton, New Jersey, was the antithesis of Berlin. It was a sleepy, aristocratic, and deeply American small town.
The Institute for Advanced Study was not even a university. It had no students, no classes, no laboratories. It was, as its founders intended, a monastery for scholars, a paradise where the world's greatest minds would be paid simply to think. For Einstein, it was a sanctuary, but it was also a gilded cage. He was 54 years old. He was Soph. He was given a comfortable salary and a quiet office. He would live out the rest of his life in a simple two-story white house on Mercer Street. But he was haunted. He was haunted by what was happening in Europe. Every day the news grew darker. He watched from his peaceful remove as the darkness he had escaped began to consume the world. He also became a lifeline. His simple house on Mercer Street became a crucial way station for the flood of intellectual refugees fleeing Europe. He wrote endless letters of recommendation, affidavits, and pleas, using his immense fame and influence to secure visas and university positions for countless scientists, artists, and thinkers who, like him, had been cast out. His scientific life, however, had become one of profound, self-imposed isolation. He was the lion in winter. The physics community had moved on. The new physics was quantum mechanics. Young, brilliant minds were using it to unlock the secrets of the atom, to build particle accelerators, to discover new frontiers. Einstein, in his quiet office, would have none of it. He set himself apart on a final, grand, and ultimately lonely quest, the search for a unified field theory. This was his holy grail. He believed that all the forces of nature, gravity, which he had described, and electromagnetism, which Maxwell had described, were not separate. He believed they were just different manifestations of one single, underlying geometric structure. He was searching for an equation, perhaps just 1 inch long, that could describe the entire universe. From the orbit of a planet to the flicker of a light bulb, it was a quest for the mind of God, the ultimate blueprint. Year after year, he worked on it. He would fill notebooks with tensor equations, grow excited, announce a breakthrough, and then, months later, find a flaw and quietly retreat, starting all over again. His colleagues at the Institute, like the physicist Robert Oppenheimer, watched him with a mixture of reverence and sadness. They revered him as the living legend who had founded their field, but they came his quest for a unified theory as a noble but ultimately doomed obsession. He was, in their view, a relic stuck in the past, searching for a classical, deterministic God in a universe that had proven to be probabilistic and strange. In 1936, his personal world shrank once more. His wife, Elsa, who had been his companion, his protector, and his gatekeeper against the world's demands, died after a painful illness. He was now truly alone, with his equations, his violin, and the terrible gathering storm in Europe. Chapter 15. The Letter, 1939. The year 1939 was a tipping point. In Germany, scientists Otto Hahn and Fritz Strassmann, building on the work of Lise Meitner, had done the unthinkable. They had split the uranium atom. They had achieved nuclear fission. The news spread through the physics community like a shockwave. Lise Meitner, herself a refugee in Sweden, realized the implication. The process released not only energy, but also more neutrons, which could go on to split more atoms. A chain reaction. An atomic bomb was now, suddenly, a theoretical possibility. In America, a small group of Hungarian refugee physicists, Leo Szilard, Eugene Wigner, and Edward Teller, were terrified. They knew the caliber of the German scientists. They knew that if Hitler's regime, which was at that very moment preparing to invade Poland, were to acquire such a weapon, the world would be lost. They needed to warn the American government. But they were unknown refugees. No one would listen to them. They needed a voice. They needed the one man on Earth the president would listen to. They needed Albert Einstein. In July 1939, Szilard and Wigner drove to Einstein's summer cottage in Peconic, Long Island, where he was sailing, lost in his unified field equations. They found him, relaxed, in slippers. They began to explain in German the possibility of a uranium chain reaction. Einstein, who was so detached from the new quantum physics, had not even considered it. As Szilard explained, Einstein's face paled. He interrupted him. "Daran habe ich gar nicht gedacht," he murmured. "I had not even thought of that." The pacifist, the man who had loathed war his entire life, was now faced with the most terrible moral dilemma of the modern age. If he did nothing, Hitler might get the bomb first. The consequence of his inaction could be the enslavement of the world. If he spoke up, he might trigger a horrific arms race, creating the very kind of weapon his pacifist soul abhorred. His choice, in the end, was clear. The danger that Hitler might be the one to do it, he later said, was the only thing that swayed me. He agreed. He would sign. Szilard drafted a letter to President Franklin D. Roosevelt. Einstein read it, suggested changes, and signed his name. The letter, dated August 2, 1939, is one of the most fateful documents in history. It is calm, but its message is terrifying. It warns the president of the new physics, the possibility of extremely powerful bombs of a new type, and urges the administration to secure uranium and fund research. The letter was delivered to Roosevelt. It set in motion the chain of events that would lead, slowly at first, and then with incredible speed, to the creation of the Manhattan Project. Einstein, the lifelong pacifist, had, with his signature, initiated the nuclear age. He himself would have no part in the project. The U.S. government, aware of his pacifist leanings and his subversive reputation, classified him as a
security risk. He was kept completely in the dark. While thousands of scientists gathered in the secret city of Los Alamos, Albert Einstein, the man whose E equals mc squared was the very foundation of their work, remained in his quiet office in Princeton, a lion in winter, working alone on his unified field theory. Chapter 16. The Conscience of the World, 1945. On August 6, 1945, Albert Einstein was at his summer home. His secretary, Helen Dukas, brought him the midday news. The United States had dropped a new kind of bomb on a Japanese city called Hiroshima. Einstein was stunned. He reportedly uttered, "Oh my God." He had known the bomb was possible. He had not known it was imminent. He had not known the scale of the project, nor the terrifying, world-ending power it would unleash. The public, however, immediately connected the bomb to its most famous equation, E equals mc squared. The father of relativity was now, in the popular mind, the father of the atomic bomb. It was a title he rejected, but a responsibility he could not escape. Had I known that the Germans would not succeed in developing an atomic bomb, he later said, I would have done nothing. I would have burned my fingers before I wrote that first letter. The explosions over Hiroshima and Nagasaki, and the dawn of the Cold War that immediately followed, galvanized him. It gave his final years a new, desperate, and urgent political purpose. He was no longer just a pacifist. He was an anti-nuclear advocate. He threw his immense moral authority into the cause. He became the chairman of the Emergency Committee of Atomic Scientists, a group dedicated to educating the public about the dangers of nuclear weapons. They raised money, they published articles, they gave speeches. Einstein was their figurehead.
his face on their pamphlets, his voice on the radio, warning that humanity was at a crossroads. The old physics, he argued, had led to a new, terrible reality. Now, a new kind of political thinking was required. His solution was as radical as his physics: one world government. He argued that nationalism, the measles of mankind that had caused 2 world wars, was now an existential threat. As long as individual nations had sovereign control over this new weapon, a global, species-ending war was not just possible, but inevitable. The only answer, he said, was to create a new global political body, a world federal government that would have sole, exclusive control over all nuclear technology. It was, of course, a utopian, idealistic, and politically impossible dream, especially in the frozen, paranoid atmosphere of the Cold War. He was dismissed by politicians as a naive dreamer, a well-meaning old man who understood equations, but not human nature or power. But he would not be silent. As the new anti-communist paranoia of the McCarthy era began to sweep America, Einstein, the old rebel, stood firm. He advised witnesses to engage in civil disobedience, to refuse to testify before the House Un-American Activities Committee, even if it meant jail and economic ruin. He had become, in his final years, the conscience of the world. A man who had seen the mind of God in the structure of the cosmos, and who now saw only madness in the hearts of men. Chapter 17, The Unfinished Symphony, 1948 to 1955. As his political voice grew more urgent, his scientific voice grew quieter. The final decade of his life was spent in that quiet office at Princeton, walking the same path between his home on Mercer Street and the Institute, a familiar, stooped figure in an old sweater, lost in thought. His quest for the unified field theory had become his everything. It was his daily work, his solace, and his private obsession. He was searching for the final, elegant equation that would unite gravity and electromagnetism to prove that his dice-playing quantum colleagues were wrong, and that the universe was, after all, a single, magnificent, logical, and knowable design. His colleagues no longer argued with him. They watched from a respectful distance. He would publish new versions of his theory, only to retract them. The physics world had passed him by. They were smashing atoms and discovering a zoo of new, bizarre subatomic particles, while Einstein, the old master, was lost in his classical geometric dreams. He was not bitter. He was simply detached. He had done his work. He had set the world on its course. Now he was following his own path, a lone traveler to the very end. In 1948, his first wife, Mileva Maric, the woman who had been his partner at the very beginning, who had read his 1905 papers, and who had lost her own dreams to his, died alone in Zurich. In 1952, a different kind of offer came. The first president of the new state of Israel, Chaim Weizmann, died. The Israeli government formally offered the presidency to Albert Einstein. He was, after all, the world's most famous and respected Jew. Einstein, now 73, was deeply moved, but he gently declined. He wrote in a beautiful, humble letter that he lacked the natural aptitude and the experience to deal properly with people. But his real reason was simpler. "Equations are more important to me," he said, "because politics is for the present, but an equation is something for eternity." He returned to his notebooks, filled with the mathematics of his unfinished symphony. In April 1955, his health, which had been frail for years, finally failed. He suffered a rupture of an abdominal aortic aneurysm. He was rushed to Princeton Hospital. His doctors advised immediate surgery. It was a chance, perhaps, to prolong his life. Einstein, now 76, refused. His philosophy was as clear in death as it had been in life. He said, "It is tasteless to prolong life artificially. I have done my share. It is time to go. I will do it elegantly." In the early morning hours of April 18, 1955, Albert Einstein died. He had asked for no ceremony. He wished to be cremated, his ashes scattered in a secret, undisclosed location to prevent his grave from becoming a circus, a shrine. On his bedside table, the nurse found a clipboard. On it were 12 pages of new calculations, a final frantic attempt to grasp the unified theory that had eluded him for 30 years. He had been working, literally, until his very last breath. Chapter 18. The Legacy of a Star. Epilogue. What is the legacy of a man who becomes a myth? There is the scientific legacy, of course. It is so vast, we swim in it without knowing. The lasers in our scanners, the GPS in our phones that must account for relativistic time dilution, the nuclear power that lights our cities, and the quantum mechanics that run our computers, all bear his fingerprints. He is a co-author of our modern reality. And then there is the intellectual legacy. He taught us how to think. He showed us that the most powerful laboratory is the human mind, that the most important questions are the simple, childlike ones. Why? What if? He proved that all the common sense of the world, all the things we know to be true, can be shattered by a single, beautiful, contradictory thought. But perhaps his truest legacy is not in his physics, or even in his philosophy. It is in the image he left behind. The image of the gentle, rebellious, humane scientist. The man with the mischievous eyes and the halo of white hair, sticking his tongue out at authority. In a century defined by brutal, impersonal forces, by war, by ideology, by the atom bomb he so feared, Einstein became the symbol of the individual human conscience. He was a deeply imperfect man. He was a difficult husband, an often absent father. He was stubborn, arrogant, and isolated in his final years. He was, in other words, profoundly human, but his life story remains a beacon. It is a reminder that the universe is not just a collection of cold, dead facts, but a source of boundless, awe-inspiring mystery. His brain was preserved, studied, and sliced in a morbid attempt to find the physical source of his genius, but they were looking in the wrong place. His genius was not in the tissue. It was in his unyielding curiosity, in his courage to reject authority, and in his profound, almost spiritual belief in a hidden, beautiful, and understandable order to the cosmos. He never found his unified field theory. The symphony was left unfinished, but he gave us the opening notes. He taught us to listen. And so, as you drift towards sleep, perhaps you can imagine the young Albert looking at that simple compass, or the 16-year-old dreaming of riding a beam of light. He left us not with a set of final answers, but with a universe of better questions, and a quiet, enduring sense of wonder. Good night,